This is topic 13-1, multiplying monomials. Our objective today is I can use properties of exponents to simplify expressions involving multiplying monomials. So our essential question is, how can I use properties of exponents to simplify expressions involving multiplying monomials? By the end of this topic, you should be able to answer that question. Our bell work is a review problem. So for a line in y equals mx plus b, where m is greater than 0 and b is less than 0, what change would occur if b is multiplied by -1 and m remains constant? So what we need to know is, what does m and what does b stand for? Our m is our slope. So the m greater than 0 tells you that the slope is positive. If it is greater than 0, it is positive. That's information we need to know. The other information that they give you is that b is less than 0. b is our y-intercept. So our y-intercept is negative. Now it's asking, what change would occur if b, this is our y-intercept, is multiplied by a -1? So if our y-intercept was initially negative, we're going to get a negative times a negative, which gives us a positive. So if our b was multiplied by -1, this means our y-intercept is positive. And m remains the same, and that means our slope is the same, which means it is also positive. Now let's look at the answers. A says the y-intercept would become negative. Well, it started off negative, but it was multiplied by negative. It is now positive. So A is not true. B says the slope will become negative. The slope stayed the same, and it was positive. So B is not true. C says the resulting line would be perpendicular to the original line. This means that their slopes are opposite reciprocals. That means our slope of our original has to be the opposite reciprocal of the slope of the new one, or that they are different to each other. But we know that our slopes are the same, so C is not it. D says the resulting line would be parallel to the original line. If the lines are parallel, that means they have the same slope. They will not touch and they have the same slope. And sure enough, it says our slope is the same or remains the same, and so D is our correct answer. So now let's talk about multiplying monomials. We're going to expand each of the expressions in order to simplify it. So a monomial is, I have a number and a variable together, or I could just have numbers, or I could just have variables. So what I have in problem 1, we have the monomial x cubed, and we have the monomial x to the 4th. When we're dealing with exponents, the x cubed, the 3, tells us how many x's we have to multiply together. So x cubed is actually x times x times x. There's 3 of them. Then we're going to multiply that by x raised to the 4th power. Again, the exponent tells us how many x's we're multiplying together. So we have 4 of them. 1, 2, 3, 4. So we have expanded it. Now we want to simplify. Now I want to put it back in the form of x raised to a power. So if initially the exponent tells you how many to stamp out, then I should be able to write this raised to an exponent of how many times we have the x there. So let's count them. There's 1, 2, 3, 4, 5, 6, 7. This will be x raised to the 7th power. If I work backwards again and take an x and stamp it out, I would stamp out 7 x's, which is what we had in the middle here. So now we have a monomial that has both a number and a variable, 5y squared, and it's multiplied by another monomial, 6y to the 6th power. So in multiplying these two monomials together, we want to take the numbers and multiply the numbers together, and then we want to take the variables that are alike and expand them and simplify them. So let's start off with the numbers. Our first monomial of 5y squared, we have the number 5, and then I will cross it out because all I'm doing is rewriting so my numbers are first. And in the second monomial we have 6, so it's going to be times 6. Now we have our y's. So the first one is y squared. That means I have 2 y's. Stamping it out. And the second one is y to the 6th. So I'm going to stamp it out 6 times. 1, 2, 3, 4, 5, 6. Should be a y, not a 6. And we've taken care of that. So we have rewritten. Now we can go ahead and let's multiply the first two numbers. 5 times 6 is 30. And then we want to, again, simplify this number of y's. Let's count how many we have. 1, 2, 3, 4, 5, 6, 7, 8. So this will be y raised to the 8th power. We have 8 of them stamped out. Now what we have done is really a property of exponents. We've just shown a whole lot of steps to get there. When our exponents are small, like x to the 3rd power, x to the 4th power, stamping them out is not a problem. However, when you start getting to problems where you have a variable raised to like the 15th or even the 25th or 100, you do not want to write out x 100 times. So we can use our property of exponents. Our property of exponents states that for every non-zero number b, and we use the letter b because it represents, we call this a base, and that base can be any non-zero number. So basically what I have is I have a number, that base raised to the power of m, and I'm going to multiply it by another number that has the same base, but now it's raised to a power n. Then my result can be that same base we started out with in both of those, and then it's m plus n. So what you'll notice is I start off with the same base and I end with the same base. The only thing that changes is the exponent, and we're going to add those exponents. So for example, in our previous ones on number 1, when we had x to the 3rd times x to the 4th, that's x and then 3 plus 4. We still have the base of x, but 3 plus 4 equals 7 is now our new exponent. So let's look at our first one. We have x to the 15th power times x to the 3rd power. So we start off with x's. That means our base is still x, but now we're going to take these exponents and add them together. 15 plus 3, and this will give us x raised to the 18th power. Our second example, we're doing the exact same thing. Notice I have 2 raised to the 15th power and 2 raised to the 3rd power. So that means my answer must be a 2, but I'm going to now raise it to the power of 15 plus 3, or 2 raised to the power of 18. And so we have simplified those monomials, multiplying those monomials using our properties of exponents. Properties of exponents here means if I'm multiplying with the same base, then I can add their exponents. Let's do some applications now. We have 3n raised to the 5th power times, 2n raised to the 5th power times 3n to the 4th power. So we're going to begin by writing our numbers first. So we got a 2 from our first monomial times 3 from the second one. And as I write them down, I'm going to cross them out so I will not write them down again. Then we have an n to the 5th from our first one times n to the 4th from our second. And again, once I write them, I'm going to cross them out. So now we can multiply the numbers out front, and notice these have different bases. One is a 2, the other number is a 3. So I can't rewrite them. I can just multiply them out. 2 times 3 is 6. And then our n, we know we'll have, again, a base of n, and this time we'll do 5 plus 4, and that is 9. So our answer is 6 times n to the 9th power. Number 4, we're using parentheses instead of the little dot. We're still doing multiplication. So let's start with our numbers. We got 7, and then 3. So we'll do 7 times 3. And now let's look at our n's. In the first parenthesis, we have an n. There's not an exponent shown, but just like when we've had problems with variables with no number in front, we understood there was an understood 1. If there's not an exponent shown, it's an understood 1 up there because I only have one n. So I'm going to go ahead and write that 1 there. And then times n to the 5th power. So now let us multiply 7 times 3, that's 21. And then n, we have 1 plus 5 is 6. So our answer is 21 times n to the 6th power. Number 5, following that same process, let's do our numbers first. So we have a negative 3 out front. times a positive 5. Look at our a's. We have a squared from our first parenthesis times a, and we're going to put a 1 power, and then b cubed times b to the 4th. So our final answer, negative 3 times 5 is a negative 15. We have a to the 3rd power and b to the 7th power. Again, we're same bases, we can add those exponents. 2 plus 1 is 3, 3 plus 4 is 7. Problem number 6. In our first parenthesis, we have a 2. In our second parenthesis, I don't have any number, but again, I always know there's an understood 1 in front of any variable unless there's a different number shown. So I could say times 1. And then in our last parenthesis, we have a negative 3, so times negative 3. Let's look at our a's. From the first parenthesis, we have a to the 1 power. Second parenthesis, we got a to the 1 power. In the last parenthesis, we have a squared. First parenthesis, we have b to the 1 power. Second parenthesis, we got b to the 1 power. And the last parenthesis, we have b to the 5th power. So now let's simplify. 2 times 1 is 2, times a negative 3 is a negative 6. My a's, we have 1 plus 1, that's 2, plus another 2 is a total of 4. For the b's, we have 1 plus 1, it's 2, plus 5 is 7. So our answer is negative 6, a to the 4th power, b to the 7th power. Number 7, do not be afraid because you have fractions. We're still going to follow the same process. Let's start with our numbers. And the number that we have is 20 divided by 3, or 20 over 3. That comes from our first parenthesis. Our second parenthesis, we have 12 over 5. So I'm going to multiply that by 12 over 5. We've taken care of the numbers. Now we have our variables. So we have x squared times x cubed from our second parenthesis. First parenthesis, we have a y. We'll put that to the 1 power and a y to the 5th power. I tell you not to be afraid of the fractions because you can always use your calculator. So if you take out your calculator and turn it on, we can type in those fractions into our calculator. And when you're typing in fractions, remember to put them in parentheses. So we're going to start off with open parenthesis, 20 divided by 3. Close the parenthesis, open the parenthesis, 12 divided by 5. And because we're using parentheses, that tells us we are definitely multiplying those two fractions together. When you press enter, we get it equals to 16. So multiplying these two fractions together gives us 16. And now we can finish off the rest. We'll have x to the 5th power and y to the 6th power. Now we want to find the area of the shaded region. The shaded region is in a funny kind of shape, and so we need to use shapes that we know an area formula for. And we know the area formula for rectangles or squares. So we're going to break this into 2 different shapes. I'm going to cut it down, and your shape doesn't necessarily have to match mine. You just need to make sure that you can find the area of the shapes you're coming up with. So I'm going to start off with a long rectangle here, or a tall rectangle. And I'm going to outline it so you can see in blue. And this rectangle has a length of 5 BC and it has a width of 5 BC. So remember, the BC is just those variables that just represent numbers, knowing that the numbers are different. So in order to get the area of my first rectangle, call this area of 1, we're going to get length, which is 5 BC, times the width, which is just BC. If I follow my same pattern as before, I'm going to do my numbers. So this is 5 times, that takes care of the numbers. Let's look at the letters, B times B, and then C times C. And this ends up as 5 B squared, because there's 1's here, 1 plus 1 is 2, and then C squared. Now I want to look at my second shape. This is also a rectangle. I know the top part is 4BC, so that can be my length. Now I'm trying to find out what's my width, what's that other side. And I don't know what it is right now, but I see that, hey, that width is a part of what my original or the first rectangle was. I know that this entire side is 5, but I am going to take away 1 BC and another BC. So if I have 5 minus 1 for this piece and 1 for this piece, that is going to leave that my width is 3 BC. There should be 3 of them left. So now the area for my rectangle, second rectangle, is 4 BC times 3 BC. Again, let's start with the numbers. We'll have 4 times 3, then B times B, and C times C. 4 times 3 is 12. We have B squared and C squared. Now to get the area, I need to combine those. And combine means I'm going to add. So to get the total area, I have to add the area from the first one and the area from the second one. So I can say 5 plus 12, that is 17. And my variables must stay the same of B squared, C squared. This comes back to combining like terms. Notice we did not change what the variables were because we are not multiplying the 5 and the 12. We are adding them together. So when we're adding, those last terms are going to stay the same. So our area for the total is 17 B squared C squared. Our last problem is a word problem. We want to find the area in square units of a rectangle that has a width of 2x squared y cubed. I'm going to draw a picture. And has a length of 4x to the 5th y cubed. Area is length times width. So we're going to multiply the two. And I'm going to save some steps. Let's start off with our numbers. We have a 2 and a 4. And then we have x squared times x to the 5th. And last we have y cubed times y cubed. So multiplying, 2 times 4 is 8. We have 7 x's, so x to the 7th power, and then y to the 6th power. So now summarizing, when we're given monomials that are multiplied together, the first thing we did was we rewrote the expression. So we're going to rewrite the expression. Putting the numbers together. That's what we did in our last problem, put the numbers together and the like variables together. Then we're going to use the properties of exponents. To simplify the multiplication and the way that we did that is that if they have the same base, you will keep the base and add the exponents. So keep the base means the base stays the same. And add the exponents. And I'm going to even give a little example. So like x squared times x cubed would be x to the 5th. This concludes topic 13-1.